What if everything we thought we knew about the beginning of the universe is fundamentally wrong? What if the Big Bang wasn't actually the beginning at all, but merely the transition between one cosmic epoch and another? This isn't science fiction or wild speculation. This is the revolutionary claim being made by Sir Roger Penrose, a Nobel Prize-winning physicist whose mathematical genius helped prove that black holes must exist. And his theory doesn't just challenge our understanding of cosmic origins, it suggests that our entire universe is caught in an endless cycle of death and rebirth, stretching infinitely into both the past and future. Welcome back to another journey into the profound mysteries that shape our reality. I'm here to guide you through one of the most fascinating and controversial ideas in modern cosmology. Today, we're going to explore how a brilliant mathematical physicist is quietly dismantling one of science's most sacred theories. So settle in, take a deep breath, and prepare to have your conception of existence gently turned upside down. Before we dive into this cosmic rabbit hole, I'd love to know where you're listening from tonight. Are you curled up under the stars somewhere, pondering the vastness above? Or perhaps you're in a quiet room, letting these ideas wash over you like waves on a distant shore? Drop a comment and let me know what time it is in your corner of the universe. To understand why Roger Penrose's latest theory is sending shockwaves through the scientific community, we first need to appreciate just who we're dealing with. So Roger Penrose isn't some fringe theorist working in isolation. He's one of the most respected mathematical physicists alive today, a man whose insights have fundamentally shaped our understanding of reality itself. Picture this: it's 1965, and the scientific world is grappling with one of Einstein's most troubling predictions. Einstein's general theory of relativity suggested that, under certain conditions, matter could collapse into infinitely dense points called singularities. These would be regions where the very fabric of space-time breaks down, where the laws of physics, as we know them, simply cease to function. Even Einstein himself found this idea so disturbing that he refused to believe such objects could actually exist in nature. But Penrose saw something that Einstein had missed. Using ingenious mathematical techniques, he proved that these cosmic monsters we now call black holes aren't just theoretical curiosities. They're inevitable consequences of Einstein's own equations. When massive stars collapse, Penrose showed, they must form singularities. There's no escape clause, no mathematical loophole. The universe simply has no choice but to create these regions where space and time themselves come to an end. Take a moment to absorb that profound realization. Here was a young mathematician proving that one of the greatest minds in history had been wrong about the implications of his own theory. It's as if someone had discovered a hidden room in a house that the architect insisted couldn't exist. For this groundbreaking work, Penrose was awarded the Nobel Prize in Physics in 2020, sharing the honor with astronomers who confirmed that our own galaxy harbors exactly the kind of supermassive black hole his mathematics predicted. The Royal Swedish Academy of Sciences called his 1965 paper the most important contribution to the general theory of relativity since Einstein. But Penrose wasn't finished revolutionizing our understanding of the cosmos. Having proven that the universe could create regions where space-time ends, he began to wonder about the opposite question. If the universe could have endings, what about beginnings? What if the Big Bang itself wasn't really the start of everything, but something more like a transition, a cosmic phase change from one epoch to another? To understand why Penrose began questioning the Big Bang, we need to confront one of cosmology's most perplexing puzzles. It's a problem so profound that it strikes at the heart of everything we think we know about how the universe works. Imagine you're watching a movie of the universe playing in reverse. Stars collapse back into gas clouds. Galaxies merge and scatter. The cosmic web of matter contracts and simplifies. As you wind the clock backward, you see the universe becoming smaller, hotter, and 13.8 billion years ago, more ordered. Eventually, You reach a point about when everything we can observe was compressed into a region smaller than a proton, with temperatures and densities beyond imagination. This is the Big Bang, the moment when our observable universe burst into existence. But here's the puzzle that has kept cosmologists awake at night. Why was the early universe so incredibly, impossibly organized? Think about it this way. Drop a deck of cards and they'll scatter randomly across the floor. The chances of them landing in perfect numerical order are so vanishingly small that you could drop cards for the entire age of the universe and never see it happen. Yet the Big Bang seems to have started with the cosmic equivalent of a perfectly ordered deck. The early universe was in what physicists call a state of extremely low entropy. Entropy is a measure of disorder, and according to the second law of thermodynamics, entropy always increases over time. Things become more scattered, more random, more chaotic. It's why your room gets messy if you don't clean it, why hot coffee cools down, why perfume spreads through a room. But if entropy always increases, then looking backward in time, it must have been even lower in the past. The Big Bang represents the ultimate low entropy state, a condition so precisely ordered that Penrose has calculated the odds of it occurring by chance. The number he arrived at is so staggeringly small that it defies comprehension. 1 part in 10 to the power of 10 to the power of 123. Let me put that in perspective for you. If you tried to write this number out in full, using every atom in the observable universe as a zero, you wouldn't have nearly enough matter to complete it. It's a level of fine-tuning so extreme that it makes winning the lottery every day for 1 billion years look like a sure bet. This is what philosophers call the past hypothesis, the assumption that the universe began in an extraordinarily special, low-entropy state. Without this assumption, we simply cannot explain why we see the structured, organized cosmos around us today. Galaxies, stars, planets, and life itself all depend on this initial cosmic order. But why should the universe have started this way? What mechanism could have set up such precise initial conditions? This question has haunted cosmologists for decades, leading to increasingly exotic theories to explain our cosmic origins. In the 1980s, physicist Alan Guth proposed what seemed like an elegant solution to the fine-tuning problem. He suggested that in the first fraction of a second after the Big Bang, the universe underwent a period of exponential expansion called cosmic inflation. During this brief epoch, space itself stretched faster than light, smoothing out any initial irregularities and creating the uniform conditions we observe today. Imagine a wrinkled balloon being inflated so rapidly that its surface becomes smooth and flat. That's essentially what inflation theory proposes happened to the early universe. Any initial chaos or disorder would have been stretched out beyond our observable horizon, leaving behind a cosmos that appears perfectly organized on the scales we can measure. Inflation theory has been remarkably successful in explaining many features of our universe. It accounts for why the cosmic microwave background radiation, the afterglow of the Big Bang, appears so uniform in all directions. It explains the large-scale structure of galaxies and the tiny fluctuations that served as seeds for cosmic evolution. For decades, it has been the dominant paradigm in cosmology, but Penrose sees fundamental problems with this picture. As you sit there, listening to these ideas unfold, consider this. Inflation may solve the homogeneity problem, but it doesn't really address the deeper question of why the universe began in a state capable of inflating in the first place. It's like explaining why a movie has a coherent plot by saying the editor did a good job, while ignoring the question of where the original screenplay came from. Moreover, inflation requires its own set of highly specific initial conditions. The scalar field that drives inflation must start with just the right energy density and spatial distribution. The laws of physics themselves must be perfectly calibrated to allow inflation to occur and then stop at exactly the right moment. In some sense, inflation simply pushes the fine-tuning problem back one step without truly resolving it. Penrose began to suspect that cosmologists were approaching the problem from the wrong direction entirely. Instead of trying to explain why the Big Bang started with such low entropy, what if there was no beginning at all? What if our universe was simply the latest chapter in an infinitely long story? This is where Penrose's revolutionary thinking takes a dramatic turn. In 2010, he published a book called Cycles of Time that outlined a radically different vision of cosmic history. Instead of a universe that began with the Big Bang and will end in heat death, Penrose proposed something caught in an eternal cycle of death far more profound, a cosmos and rebirth. He calls this theory Conformal Cyclic Cosmology, or CCC for short. The name might sound technical, but the core idea is beautifully simple. Our universe, according to Penrose, is just one aeon in an infinite sequence of cosmic epochs. Each aeon begins with something like a Big Bang, evolves for billions of years, and eventually reaches a state where it can seamlessly transition into the next aeon. Picture the universe as an endless spiral, with each loop representing a complete cosmic cycle. We're currently living somewhere in the middle of one of these loops, but there were infinitely many loops before us, and will be infinitely many after we're gone. But how could such a cycle possibly work? How could a universe that's expanding and cooling eventually loop back to become a new Big Bang? This is where Penrose's mathematical genius shines through, revealing connections between the largest and smallest scales of reality that no one had imagined before. The key insight involves the far future of our universe, trillions upon trillions of years from now. According to our current understanding of physics, the cosmos will continue expanding and cooling until it reaches a state cosmologists call heat death. All the stars will burn out, all the black holes will evaporate through Hawking radiation, and the universe will be filled with nothing but photons, particles of light that carry no mass and experience neither space nor time. Here's where Penrose made a startling observation. In this ultimate future state, with only massless particles remaining, the concepts of size and scale become meaningless. A universe that has expanded to infinite size looks, mathematically speaking, identical to a universe that has contracted to infinitesimal size. Both states can be described by the same equations, the same geometry. This mathematical equivalence provides the bridge between endings and beginnings. The end of one aeon, when the universe has expanded to infinity and contains only massless particles, can be conformally mapped onto the beginning of the next aeon, when the universe emerges from a Big Bang singularity. It's a bit like the way a circle has no beginning or end. You can start at any point and travel around the circumference, eventually returning to where you started. Penrose suggests that cosmic time might work the same way, forming a closed loop that connects the infinite future to the infinite past. As you contemplate this possibility, notice how it transforms our understanding of existence itself. We're not temporary accidents in a universe heading toward oblivion. We're part of an eternal dance of cosmic evolution, players in a story that has no beginning and no end. But there's still a crucial piece missing from this cosmic puzzle. Even if the geometry allows for cyclical transitions, what about the entropy problem that started this whole investigation? How could a universe in heat death, with maximum entropy and disorder, transform into a new Big Bang with minimum entropy and perfect order? This is where black holes enter the picture in a most unexpected way. Throughout cosmic history, these gravitational monsters have been devouring matter and energy, growing ever more massive as they consume everything that falls into their event horizons. But according to Stephen Hawking's groundbreaking work, black holes aren't truly black. They emit radiation and slowly evaporate, eventually disappearing entirely. Penrose realized that this evaporation process has profound implications for cosmic entropy. When matter falls into a black hole, it carries information with it. This information appears to be destroyed when the black hole eventually evaporates, effectively removing entropy from the universe. Black holes act as cosmic vacuum cleaners, sucking up disorder and complexity. In the far future, as the universe expands and cools, these black holes will be the last massive objects remaining. They'll spend eons slowly evaporating, each one taking its entropy with it into oblivion. By the time the last black hole disappears, the universe will have returned to a state of incredibly low entropy, perfectly prepared for the next Big Bang. It's an elegant solution that turns one of general relativity's most mysterious predictions into the engine of cosmic renewal. The same objects that Einstein refused to believe in become the mechanism that allows the universe to reset itself for the next cycle. But wait, there's more to this story. Penrose doesn't just propose this theory as an abstract mathematical possibility. He claims to have found actual evidence for it, hidden in the cosmic microwave background radiation that fills our sky. And this is where the scientific controversy really begins. Take a deep breath and prepare yourself. What we're about to explore next will challenge everything you thought you knew about observation, evidence, and the nature of scientific truth itself. Because when a Nobel Prize winner claims to see traces of a previous universe in our cosmic baby photos, the implications stretch far beyond physics into the very foundations of how we understand reality. As we'll discover, sometimes the most profound truths hide in the quietest whispers of ancient light. Picture yourself standing in the world's quietest place, a chamber so silent that you can hear your own blood flowing. Now imagine that, in this perfect stillness, you begin to detect the faintest possible sound, a whisper so soft it barely disturbs the silence. This is what it's like when cosmologists study the cosmic microwave background radiation, the afterglow of creation itself, searching for the subtlest patterns that might reveal secrets from the dawn of time. This ancient light, stretched and cooled by nearly 14 billion years of cosmic expansion, fills every cubic centimetre of space around you. Right now, as you sit listening to these words, millions of these primordial photons are passing through your body, carrying messages from an epoch when the universe was younger than a human lifetime. Most of the time, this background radiation appears remarkably smooth and uniform, like a gentle cosmic hum with tiny variations that barely register on our most sensitive instruments. But Penrose believed that if his cyclic theory were correct, this ancient light should contain something extraordinary. The faint impressions of catastrophic events from the previous universe. Think of it like archaeological layers in the Earth's crust. Each stratum tells a story of the geological epoch that created it. Penrose wondered whether the cosmic microwave background might work the same way, preserving fossils of cosmic history that predate our own Big Bang. Working with his colleague Vahi Gurzadian, Penrose began analysing 7 years of data from NASA's Wilkinson Microwave Anisotropy Probe, one of our most sophisticated cosmic observatories. They weren't looking for the usual fluctuations that cosmologists study. Instead, they searched for something much more specific: concentric circles of unusually low temperature variation scattered across the sky. According to Penrose's theory, these circles should be the signatures of something almost unimaginable. In the previous universe, during its final eons, massive black holes would have wandered through the expanding cosmos, like titans in a vast empty arena. Occasionally, two of these cosmic giants would spiral toward each other, locked in a gravitational dance that could last longer than our current universe has existed. When these black holes finally collided and merged, they would have released gravitational waves of unprecedented power, ripples in space-time itself that would propagate outward like rings on a cosmic pond. These waves would have been among the last major events in the previous universe, occurring just before the transition to our current cosmic epoch. As you absorb this possibility, consider the profound implications. We might be seeing the shadows of events that occurred before time, as we understand it, even began. It's as if we discovered that our family photographs contained ghostly images of ancestors who lived before photography was invented. In 2010, Penrose and Gurzadian announced they had found exactly what the theory predicted. Hidden within the cosmic microwave background, they identified numerous concentric circles where the temperature variations were significantly smaller than the surrounding regions. These weren't random patterns or instrumental artifacts. They appeared to be genuine cosmic signatures, potentially the first direct evidence of pre-Big Bang physics. The discovery sent ripples of excitement and skepticism through the cosmology community. If confirmed, it would represent one of the most revolutionary findings in the history of science, proof that our universe is part of an infinite chain of cosmic rebirths. But Penrose's claims didn't stop with concentric circles. As his analysis deepened, he began to identify another type of anomaly in the cosmic microwave background, features he named Hawking points in honor of his late colleague Stephen Hawking. These points appear as unusually warm spots in the sky, each roughly 8 times larger than the apparent size of the full moon. According to Penrose's interpretation, they represent something almost poetic in its cosmic significance, the final death throes of supermassive black holes from the previous universe. Imagine a black hole so massive that it contains the mass of billions of suns, slowly evaporating through Hawking radiation over timescales that dwarf the current age of our universe. As this cosmic giant approaches its final moments, it would release a tremendous burst of energy, its entire mass converting to radiation in a brief but brilliant finale. These dying black holes, Penrose suggests, would create hotspots in the cosmic microwave background that we can still detect today. Each Hawking point would be like a gravestone, marking the final resting place of a cosmic titan from the universe that came before ours. The elegance of this idea is breathtaking. Stephen Hawking's theoretical prediction about black hole evaporation, once considered purely academic, becomes a tool for archaeological investigation of previous cosmic epochs. The radiation that slowly leaks from black holes throughout their lifetimes culminates in a final burst that transcends the boundary between one universe and the next. As you contemplate this possibility, take a moment to appreciate the profound interconnectedness it reveals. The theoretical work of brilliant minds, developed through pure mathematical reasoning, might provide the key to unlocking observational evidence of realities that existed before our own cosmic genesis. Penrose claims to have identified several of these Hawking points scattered across the sky, each one potentially marking the location where a supermassive black hole from the previous universe met its spectacular end. If his interpretation is correct, we're not just observing ancient light, we're witnessing the death certificates of objects that helped shape the cosmic landscape before our Big Bang even occurred. But here's where our story takes a dramatic turn, revealing the sometimes contentious nature of scientific discovery. Within months of Penrose's announcement, 3 independent research groups had attempted to reproduce his analysis, and all 3 reached a troubling conclusion. They couldn't find the same patterns. Using the same cosmic microwave background data, but different analysis methods, these researchers found no statistically significant evidence for the concentric circles or Hawking points that Penrose claimed to have discovered. The circles appeared no more frequently than would be expected from random fluctuations in a universe governed by standard cosmological models. The disagreement wasn't simply a matter of interpretation. It traced back to fundamental differences in how the researchers constructed their analysis. Penrose and Gurzadian had used what critics called non-standard methods for determining statistical significance, while their critics employed approaches based on the well-established lambda-CDM model of cosmology. Picture 2 archaeologists examining the same ancient wall. One sees deliberate patterns and meaningful inscriptions, while the other sees nothing but random scratches and natural weathering. Both are looking at identical evidence, but their different methodological approaches lead them to opposite conclusions. The scientific community's response was swift and largely critical. Dozens of papers were published questioning Penrose's methods and conclusions, Conference presentations dissected his analysis technique by technique. The consensus that emerged was that while Penrose's theoretical framework deserved serious consideration, his claimed observational evidence was fundamentally flawed. Yet Penrose didn't retreat from his position. In 2013, he and Gurzadian published new work introducing what they called the sky twist procedure, a different analytical approach that they claimed provided even stronger evidence for their conclusions. They followed this with analysis of data from the European Space Agency's Planck satellite, arguing that it confirmed their earlier findings. This ongoing controversy reveals something important about the nature of scientific truth. Even Nobel Prize winners, even mathematical geniuses whose insights have revolutionized our understanding of reality, can find their work challenged and their conclusions disputed. Science progresses not through the pronouncements of authority figures, but through the gradual accumulation of evidence and the rigorous testing of ideas by independent researchers. As you reflect on this scientific drama, consider how it mirrors the very process of cosmic evolution that Penrose describes. Ideas like universes go through cycles of birth, growth, challenge, and transformation. Sometimes they survive the testing process and emerge stronger. Sometimes they fade away, leaving only traces of their former influence. While the scientific community continues to debate the observational evidence, Penrose's theoretical framework raises profound questions that extend far beyond any particular data analysis. If the universe truly is cyclic, if our Big Bang was merely a transition between cosmic epochs, what does this mean for our understanding of existence itself? Consider the implications for causality and meaning. In a truly cyclic universe, every event, every decision, every moment of consciousness might be part of an infinitely repeating pattern. The thoughts you're thinking right now, the breath you just took, the way light falls across your surroundings, all of this might have happened countless times before and will happen countless times again. Some interpretations of cyclic cosmology suggest that while the broad patterns repeat, the specific details might vary from one cycle to the next. Perhaps in the previous universe, the constants of physics were slightly different, leading to alternative forms of matter and energy. Perhaps in the next cycle, the fundamental forces will be rearranged, creating possibilities that our current universe cannot even contain. This raises tantalizing questions about information and memory across cosmic boundaries. If black holes can carry entropy from one universe to the next, might they also carry more complex forms of information? Could the patterns we see in the cosmic microwave background contain not just the signatures of gravitational waves and evaporating black holes, but something more subtle, more profound? Take a breath and let your imagination wander through these possibilities. What if the universe has a kind of cosmic memory, a way of preserving and transmitting information across the boundary between one aeon and the next? What if consciousness itself, in some form we don't yet understand, participates in this great cycle of cosmic death and rebirth? These are speculative ideas, far beyond what current physics can confirm or deny. But they emerge naturally from Penrose's mathematical framework, inviting us to expand our conception of what reality might actually be. As we delve deeper into the implications of cyclic cosmology, we encounter fascinating connections to quantum mechanics, the theory that governs the behavior of matter and energy at the smallest scales. Penrose has spent decades exploring these connections, developing ideas about how quantum processes might bridge the gap between mind and cosmos. In quantum mechanics, the act of observation appears to play a fundamental role in determining physical outcomes. Before a measurement is made, quantum systems exist in superposition, simultaneously embodying multiple possibilities. The measurement process somehow selects one particular outcome from this range of potential realities. Some interpretations suggest, though this remains highly speculative and scientifically unproven, that consciousness might play a role in this selection process. Penrose has proposed that quantum processes in the brain might be responsible for consciousness itself, operating through microscopic structures called microtubules that exist within neurons. If this connection between consciousness and quantum mechanics has any validity, and if the universe is truly cyclic, as Penrose suggests, then consciousness might not be a temporary accident of cosmic evolution. Instead, it could be a fundamental feature of reality, persisting in some form through the infinite sequence of cosmic cycles. Picture consciousness not as something that emerged once in the history of the universe, but as an inherent property of the cosmos itself, like gravity or electromagnetism. Each cycle might give rise to new forms of awareness, new ways of experiencing and interpreting reality, but the underlying capacity for consciousness would be eternal and indestructible. This is purely speculative territory, far from established scientific fact, but it opens up remarkable possibilities for understanding our place in the cosmic scheme. We might not be isolated observers in a universe that cares nothing for our existence. We might be integral participants in the universe's process of self-understanding, witnesses and co-creators in the eternal dance of cosmic evolution. As you sit with these ideas, notice how they might shift your perspective on existence itself. What changes when you consider the possibility that your consciousness is not a fleeting accident, but part of an infinite cosmic symphony that has been playing since before time began? The boundary between observer and observed, between mind and cosmos, begins to blur in ways that are both scientifically intriguing and philosophically profound. While we must be careful not to make claims beyond what evidence supports, we can still appreciate the beauty and wonder of these possibilities. Let's step back from the speculative realm and examine the mathematical foundation that makes Penrose's cyclic universe possible. The key insight involves something called conformal geometry, a branch of mathematics that deals with shapes and structures that can change size while preserving their essential relationships. Imagine you're looking at a photograph through a magnifying glass. The image appears larger, but the proportions and angles remain the same. A circle stays circular, parallel lines remain parallel, and the fundamental geometry is preserved even as the scale changes dramatically. This is the essence of conformal transformation. Penrose realized that the equations describing the far future of an expanding universe, filled only with massless particles, have the same mathematical structure as the equations describing the initial singularity of a Big Bang. Through conformal rescaling, the infinite future of one cosmic epoch can be mathematically mapped onto the infinitesimal beginning of the next. This isn't just mathematical sleight of hand, it represents a deep insight into the nature of space-time itself. When all massive particles have decayed or been absorbed by black holes, when only photons remain in an infinitely expanded universe, the concepts of size and duration lose their meaning. A photon experiences neither space nor time in the way we understand them. In this state, the distinction between infinitely large and infinitesimally small becomes meaningless. The mathematical description of an infinite universe containing only massless particles is identical to the description of a point-like singularity about to undergo Big Bang expansion. Think of it like a musical scale that extends infinitely in both directions. The highest note you can imagine and the lowest note you can conceive are both part of the same continuous spectrum. At the extremes, the distinction between high and low becomes a matter of perspective rather than absolute difference. This mathematical equivalence provides the bridge that allows one cosmic epoch to transition seamlessly into the next. The end becomes the beginning, not through some mysterious external intervention, but through the internal logic of the mathematics itself. As you contemplate this elegant mathematical structure, notice how it mirrors patterns we see throughout nature. Day transitions into night and back into day, Seasons cycle from winter through spring, summer, and fall, then return to winter again. Birth leads to growth, maturity, death, and then to new birth. Perhaps the universe itself follows this same fundamental pattern, cycling through phases of expansion, evolution, and renewal on the grandest possible scale. The mathematics suggest that time itself might be cyclic rather than linear. We're accustomed to thinking of time as an arrow, pointing from past toward future, from order toward disorder. But in Penrose's framework, time becomes more like a circle, or perhaps a spiral, with each revolution carrying the universe through another complete cycle of evolution. This transforms our understanding of concepts, like beginning and ending, cause and effect, permanence and change. If the universe is truly eternal and cyclic, then every moment exists within an infinite context, connected to all the moments that came before, and all those that will come after, across an endless sequence of cosmic epochs. As we continue our exploration of this profound theory, remember that we're not just discussing abstract mathematics or distant cosmological speculation. We're examining a framework that could fundamentally alter our understanding of existence, consciousness, and our place in the grand cosmic story. The implications stretch from the quantum realm to the cosmic scale, from the nature of time itself to the possibility of meaning and purpose in an eternal universe. And as we'll discover next, these ideas connect to some of the deepest questions about consciousness, reality, and the mysterious relationship between mind and cosmos. But Penrose's cyclic universe raises another profound puzzle, one that connects directly to some of the most challenging questions in modern physics. If information truly cannot be destroyed, as quantum mechanics suggests, what happens to all the complexity, all the stories, all the intricate patterns that develop during a cosmic epoch when it transitions to the next cycle? Think about the information contained in just this moment as you listen to these words. The exact position of every atom in your body, the precise pattern of neural activity in your brain, the way light scatters through the air around you. Now expand that to encompass every particle in every galaxy throughout the observable universe. The total amount of information is staggering, beyond anything we could ever hope to catalogue or comprehend. In our current understanding of physics, this information cannot simply vanish. Even when stars collapse into black holes, when galaxies drift apart, when the last atoms decay in the far future, the information must persist in some form. But how can this vast library of cosmic data survive the transition from one universe to the next? Penrose suggests that black holes might serve as cosmic librarians, not just removing entropy from the universe, but also preserving and transmitting information across the boundary between aeons. As these gravitational giants evaporate through Hawking radiation, they might not destroy the information they contain, but encode it in subtle patterns that influence the initial conditions of the next cosmic cycle. This leads us into territory where physics meets philosophy in the most intimate way. If information truly persists across cosmic boundaries, then nothing that happens in this universe is ever truly lost. Every thought, every emotion, every creative act might leave traces that echo through infinite future epochs, influencing the development of realities we'll never see. As you reflect on this possibility, consider how it might transform your understanding of significance and meaning. The conversation you had yesterday, the kindness you showed to a stranger, the moment of beauty that took your breath away, all of these might be permanent features of reality, woven into the fabric of existence itself in ways so subtle and profound that they transcend any individual lifetime or cosmic epoch. This brings us to one of the most tantalizing aspects of Penrose's work, his exploration of consciousness and its possible relationship to the fundamental structure of reality. While his cyclic universe theory stands independently of these ideas, Penrose has spent decades investigating whether consciousness might emerge from quantum processes occurring within the brain. Some interpretations suggest though this remains highly speculative and without scientific consensus, that consciousness might not be simply an emergent property of complex neural networks. Instead, it could be connected to quantum mechanical processes that operate at the boundary between the classical world we experience and the strange probabilistic realm that governs the behavior of subatomic particles. Penrose has proposed that structures called microtubules, tiny protein tubes that exist within neurons, might be capable of maintaining quantum coherence at body temperature. If this were true, it could provide a mechanism by which quantum processes contribute to conscious experience, bridging the gap between mind and the fundamental physics of reality. Now, it's crucial to understand that these ideas remain unproven and controversial within the scientific community. The brain appears to be far too warm and noisy to maintain the delicate quantum states that Penrose's theory requires. Most neuroscientists believe that consciousness emerges from classical neural processes rather than quantum mechanical ones. But take a moment to consider the profound implications if such a connection did exist. In a cyclic universe, where information persists across cosmic boundaries, consciousness might not be a temporary accident of biological evolution. Instead, it could be a fundamental feature of reality itself, finding new ways to manifest and experience existence in each cosmic epoch. This is purely speculative territory, far beyond what current science can confirm, but it opens up remarkable possibilities for understanding our place in the cosmic story. Rather than being isolated observers in an indifferent universe, we might be integral participants in the cosmos's process of self-awareness and self-understanding. As you sit with these ideas, notice how they might shift your perspective on the nature of experience itself. What changes when you consider the possibility that consciousness is not confined to biological brains, but might be a fundamental aspect of reality that finds expression through countless forms across infinite cosmic cycles? The concept of eternal recurrence has fascinated philosophers and mystics for millennia, long before modern cosmology gave us tools to investigate such possibilities scientifically. Ancient traditions spoke of cosmic cycles, of time as a wheel rather than an arrow, of existence as an eternal dance of creation and destruction. Penrose's Conformal Cyclic Cosmology gives mathematical precision to these ancient intuitions, suggesting that the universe itself might embody the principle of eternal return. But this is not simple repetition, not an endless replay of identical events. Instead, each cosmic cycle might explore different possibilities, different ways of organizing matter and energy, different paths through the landscape of potential realities. Imagine existence as an infinite improvisation, where the fundamental themes remain constant, but the specific melodies vary from one performance to the next. The laws of physics provide the underlying harmonic structure, while the specific arrangement of galaxies, stars, and planetary systems offers endless variations on these cosmic themes. In this framework, our universe becomes both unique and universal, both a singular expression of cosmic creativity and one movement in an eternal symphony. The particular combination of physical constants, the specific history of structure formation, the emergence of life and consciousness on Earth, all of these represent one possible pathway through the infinite space of cosmic possibilities. Take a breath and let yourself feel the profound interconnectedness this implies. You are not separate from the cosmic process, not an accidental byproduct of meaningless physical forces. You are the universe experiencing itself, consciousness emerging from and participating in the eternal dance of cosmic evolution. This perspective doesn't diminish the significance of individual existence, but places it within a context of infinite depth and meaning. Every choice you make, every experience you have, every moment of awareness contributes to the universe's ongoing process of self-exploration and self-understanding. As we explore these profound ideas, it's important to acknowledge the limits of what we currently know and understand. Penrose's conformal cyclic cosmology remains a minority position within the cosmological community, and his claimed observational evidence continues to face significant criticism from other researchers. The majority of cosmologists still support the standard model of Big Bang cosmology, enhanced by inflation theory, as the best explanation for the observed properties of our universe. The cosmic microwave background radiation, the abundance of light elements, the large-scale structure of galaxies, all of these observations fit well within the conventional framework. Yet this doesn't diminish the value of exploring alternative ideas and challenging established paradigms. Science progresses through the interplay between established knowledge and revolutionary thinking, between careful observation and bold theoretical speculation. Even if Penrose's specific claims prove incorrect, his work pushes us to question our assumptions and explore new possibilities for understanding cosmic origins. As you contemplate these competing perspectives, notice how they reflect the nature of human knowledge itself. We are finite beings attempting to comprehend infinite realities, using tools and concepts that evolved to help us navigate a very local and limited environment. Perhaps it's not surprising that our attempts to understand the ultimate nature of existence lead to profound mysteries and unresolved questions. The beauty lies not in having final answers, but in the ongoing process of inquiry itself. Each new theory, each novel observation, each creative interpretation adds another layer to our understanding, even when it doesn't provide definitive resolution. While these cosmological questions might seem far removed from daily life, they connect to practical questions about how we understand meaning, purpose, and responsibility in our individual existence. If the universe is truly eternal and cyclic, if consciousness persists in some form across cosmic boundaries, how does this influence the way we live and the choices we make? Some interpretations suggest that in an infinite universe with infinite cycles, every possible outcome eventually occurs somewhere, somewhen. This might seem to drain significance from individual actions and decisions. If everything that can happen does happen, do our choices really matter? But consider the alternative perspective. In an eternal cosmos where information and consciousness persist across infinite cycles, every action becomes infinitely significant. The kindness you show, the creativity you express, the love you give and receive, all of these ripple outward through space and time in ways we can barely begin to imagine. Your consciousness, your unique perspective on existence, your particular way of experiencing and interpreting reality, these might not be temporary accidents, but permanent contributions to the universe's ongoing self-exploration. In choosing how to live, you're not just affecting your immediate circumstances, but participating in the eternal process of cosmic evolution. Take a moment to feel the weight and wonder of this possibility. The thoughts you're thinking right now, the breath you just took, the way awareness moves through your experience, these might be part of an infinite conversation between consciousness and cosmos, mind and matter, individual and universal. This doesn't require belief in any specific cosmological theory or metaphysical framework. It simply invites you to consider the profound interconnectedness that links your individual existence to the larger scales of space and time, the deepest questions about the nature of reality itself. As we near the end of our exploration, let's return to one of the most puzzling aspects of quantum mechanics and its potential connection to consciousness and cosmic evolution. In quantum physics, the act of observation appears to play a fundamental role in determining physical outcomes, though the mechanism and implications of this remain hotly debated. When we observe a quantum system, we appear to cause its wave function to collapse from a superposition of multiple possibilities into a single, definite outcome. This observer effect has sparked decades of controversy about the role of consciousness in physical reality, though no scientific consensus exists about its deeper meaning. Some interpretations suggest that consciousness might be required to collapse quantum wave functions, making observers active participants in the creation of physical reality rather than passive witnesses to predetermined events. Other interpretations propose that any interaction with the environment, conscious or not, can cause wave function collapse, removing consciousness from the equation entirely. These questions become even more intriguing when considered within the framework of cyclic cosmology. If the universe undergoes infinite cycles of evolution, and if consciousness plays any role in quantum mechanical processes, then observers might participate in the ongoing creation of reality across cosmic epochs. But we must be careful not to overstate these connections or make claims beyond what evidence supports. The relationship between consciousness and quantum mechanics remains one of the deepest unsolved problems in science, and any specific claims about how mental states influence physical processes require extraordinary evidence. What we can say is that the questions themselves are profound and worthy of continued investigation. Whether or not consciousness plays a direct role in quantum mechanics. The fact that conscious beings like ourselves have emerged from the cosmic process and developed the ability to contemplate these mysteries is itself remarkable. As you reflect on your own experience of awareness, notice the profound mystery it represents. How does subjective experience arise from objective physical processes? How does consciousness relate to the quantum mechanical processes occurring within your brain? These questions remain open, inviting continued exploration and wonder. In closing our journey through these cosmic mysteries, let's consider how these ideas might influence our understanding of the present moment, the eternal now in which all experience actually occurs. Whether the universe follows Penrose's cyclic model or the standard Big Bang scenario, whether consciousness emerges from classical or quantum processes, this moment of awareness remains the fundamental reality of your existence. Take a breath and notice the miracle of this present experience. Your capacity to be aware, to reflect on cosmic questions, to contemplate the nature of existence itself, represents something extraordinary emerging from the cosmic process. Regardless of whether the universe is eternal or finite, cyclic or linear, you are here now, conscious and capable of wonder. In this moment, the entire history of the cosmos converges. The nuclear fusion processes in ancient stars created the elements in your body. The expansion and cooling of space provided the conditions for structure formation. The emergence of complexity and life led to the evolution of consciousness and the capacity for cosmic reflection. You are not separate from this process, but intimately part of it. Your thoughts, your emotions, your experience of being alive represent the universe becoming aware of itself, matter and energy organizing into patterns capable of consciousness and contemplation. This perspective doesn't require acceptance of any particular scientific theory or philosophical framework. It simply invites recognition of the profound interconnectedness that links individual awareness to cosmic evolution, personal experience to universal process. As you move forward from this exploration, carry with you a sense of wonder at the magnificent mystery of existence itself. Whether Penrose's bold vision proves correct or yields to other theories, the questions he raises about consciousness, cosmos, and the nature of reality will continue to inspire scientific investigation and philosophical reflection. The universe may or may not be eternal and cyclic, but your capacity to contemplate these possibilities, to find meaning and beauty in cosmic questions, to experience wonder at the mystery of existence, these remain profound and undeniable realities. As we drift toward the end of this cosmic meditation, remember that every ending is also a beginning. Every conclusion opens new questions. Every answer reveals deeper mysteries waiting to be explored. The conversation between mind and cosmos continues, and you are both participant and witness in this eternal dialogue. In our next journey together, we'll explore another mind-bending frontier where consciousness meets quantum reality in ways that challenge everything we think we know about the nature of mind and matter. Join me as we investigate this quantum consciousness theory terrifies scientists and discover why some researchers believe that consciousness itself might be the missing key to understanding the deepest mysteries of quantum physics. Until then, rest well in the wonder of existence, knowing that you are part of something infinitely larger and more mysterious than any theory could fully capture. The cosmos dreams through you, and in your consciousness, the universe experiences itself in ways both intimate and eternal. As we drift deeper into the implications of Penrose's revolutionary ideas, we encounter one of the most puzzling aspects of his theory that connects directly to the deepest mysteries of quantum mechanics itself. The measurement problem, that strange phenomenon where quantum systems seem to exist in multiple states simultaneously until observed, takes on entirely new dimensions when viewed through the lens of cyclic cosmology. Consider what happens when we try to measure the cosmic microwave background radiation that Penrose claims contains evidence of previous universes. Every photon detector, every satellite instrument, every analysis algorithm represents an act of quantum measurement on a cosmic scale. We're not just passively observing ancient light, we're actively participating in the process that determines what information from the previous universe becomes accessible to us. This raises profound questions about the relationship between observation and reality across cosmic timescales. If consciousness and measurement play any role in determining physical outcomes, as some interpretations of quantum mechanics suggest, though this remains highly speculative and scientifically unproven, then our attempts to detect evidence of previous universes might actually influence what evidence we're capable of finding. Take a moment to contemplate this strange possibility. The very act of searching for traces of cyclic cosmology might create a kind of cosmic observer effect, where our methods of investigation help determine what aspects of previous universes remain detectable. It's as if the universe's past becomes partially dependent on the present moment of observation. But here's where the mystery deepens even further. In Penrose's framework, observers like ourselves aren't external to the cosmic process. We're products of the current universe's evolution, patterns of matter and energy that emerge from the same Big Bang, whose nature we're trying to understand. This creates a strange loop where the universe investigates its own origins through conscious beings that are themselves part of the phenomenon being studied. Picture a cosmic hall of mirrors, where each reflection reveals new layers of self-reference and recursive complexity. The universe observes itself through conscious observers who emerged from cosmic evolution, who use quantum mechanical instruments to study quantum mechanical processes, who analyze data patterns that might contain information about how consciousness and observation functioned in previous cosmic epochs. This self-referential quality becomes even more intriguing when we consider how information might flow between cosmic cycles. In our current understanding of physics, information cannot be created or destroyed, only transformed and transmitted. But what forms might information take as it crosses the boundary between one universe and the next? Penrose suggests that black holes serve as cosmic information processors, not just removing entropy, but potentially encoding complex data patterns in the gravitational waves they emit during collision events. These waves would propagate through the fabric of space-time itself, carrying information that transcends the traditional boundaries between matter and energy. As you listen to these ideas unfold, notice how they blur the conventional distinction between information and physical reality. In quantum mechanics, information isn't just something we have about physical systems, it appears to be a fundamental aspect of physical systems themselves. The state of a quantum particle, is information, encoded in mathematical structures called wave functions that determine the probabilities of different measurement outcomes. If this perspective is correct, then the transition between cosmic cycles might involve a massive information processing event, where all the complex patterns that developed during billions of years of cosmic evolution get compressed, transformed, and transmitted to influence the initial conditions of the next universe. Imagine the entire history of our cosmic epoch, every galaxy formation event, every stellar nuclear fusion process, every moment of biological evolution, getting encoded into the subtle patterns of gravitational waves that will influence how the next Big Bang unfolds. It's a kind of cosmic DNA, carrying the genetic information of universe reproduction across the boundary between existence and non-existence. This doesn't require any mystical or supernatural mechanisms, just the natural consequences of information conservation operating on cosmic scales. Every black hole merger, every stellar collapse, every quantum interaction throughout cosmic history contributes to the information pattern that gets transmitted to the next cycle. Now we venture into territory that requires even greater caution and clearly speculative thinking. Some interpretations suggest, though this remains entirely unproven and lacks scientific consensus, that if consciousness has any connection to quantum information processes, it too might participate in this cosmic information cascade. Consider the possibility, purely as a thought experiment rather than established fact, that conscious experiences generate or correlate with specific patterns of quantum information. Every moment of awareness, every thought, every emotional experience might leave traces in the quantum field structures that pervade space and time. If such traces exist and if information truly persists across cosmic boundaries, then consciousness might not be confined to individual lifetimes or even to single cosmic epochs. The patterns of awareness that emerge in one universe might influence the potential for consciousness to develop in subsequent cycles. This is highly speculative territory, far beyond what current neuroscience or physics can confirm or deny. We must be clear that there's no scientific evidence for consciousness directly affecting quantum systems or persisting beyond biological death. But the mathematical framework of cyclic cosmology does raise intriguing questions about how information of all kinds, including patterns that correlate with conscious experience, might propagate across cosmic boundaries. As you reflect on these possibilities, notice how they might shift your understanding of individual significance within cosmic context. Rather than being isolated accidents in an indifferent universe, conscious beings might participate in an ongoing conversation that transcends any single lifetime or cosmic epoch. This brings us to one of the most beautiful paradoxes embedded in Penrose's vision. If the universe truly is cyclic, if information persists across cosmic boundaries, then in some sense the cosmos possesses a kind of memory. Yet this memory operates through mechanisms so subtle and complex that it might be forever beyond direct access. Think about your own memory system. You can recall events from your past, but the memories aren't perfect copies of the original experiences. They're reconstructions influenced by subsequent events, emotions, and the very process of remembering itself. Similarly, the cosmic memory encoded in gravitational wave patterns and quantum field configurations might preserve essential information about previous universes while transforming it in fundamental ways. The concentric circles and Hawking points that Penrose claims to detect in the cosmic microwave background would be like faint echoes of cosmic memories, traces of events so distant in time that they predate the very concept of time as we understand it. We might be seeing shadows of shadows, reflections of realities that existed in frameworks of space and time, completely different from our own. Take a breath and imagine what it would mean to live in a universe with memory, where the past isn't simply gone, but continues to influence present reality through channels we're only beginning to understand. Every sunset you witness, Every moment of beauty that takes your breath away, every act of love and creativity might contribute to patterns that echo through infinite future cycles. This perspective doesn't require belief in any specific theory or supernatural mechanism. It simply invites appreciation for the profound interconnectedness that might link individual existence to cosmic evolution in ways far more intimate and enduring than we ever imagined. As we explore these profound possibilities, we must acknowledge the fundamental challenge they pose to scientific methodology. How do we test theories about events that occurred before our universe began? How do we verify claims about information transmission across cosmic boundaries? How do we distinguish between genuine cosmic memories and patterns that arise from purely statistical fluctuations? These questions highlight one of the most important aspects of Penrose's work. Even if his specific claims about observational evidence prove incorrect, his theoretical framework pushes science toward new ways of thinking about testability, evidence, and the relationship between mathematical possibility and physical reality. Science has always operated at the boundary between the known and unknown, using established principles to explore new territories of understanding. Penrose's cyclic cosmology represents an attempt to extend this exploration to the ultimate frontier, the nature and origin of existence itself. Consider how this mirrors your own relationship with mystery and understanding. In your daily life, you navigate between what you know with certainty and what remains uncertain or unknown. The process of learning, growing, and deepening your understanding requires a willingness to hold questions without immediate answers, to explore possibilities without demanding absolute proof. The scientific investigation of cosmic origins operates in similar territory, using mathematical frameworks and observational techniques to explore questions that push against the very limits of what can be known through empirical investigation. One of the most remarkable aspects of Penrose's vision is how it democratizes cosmic significance. In the standard Big Bang model, our universe represents a unique event, a singular explosion that created everything we can observe. But in cyclic cosmology, our cosmic epoch becomes one movement in an infinite symphony, neither more nor less significant than the countless cycles that came before and will come after. This shift in perspective has profound implications for how we understand our place in the grand scheme of existence. Rather than being the sole products of a one-time cosmic accident, we become participants in an eternal process of cosmic creativity, consciousness emerging naturally from the ongoing dance of matter and energy across infinite cycles. Every star that shines, every planet that forms, every moment of awareness that emerges represents the universe, exploring its own possibilities, testing new combinations of physical laws and initial conditions, discovering new ways of organizing matter and energy into complex, beautiful, and meaningful patterns. As you contemplate your own existence within this framework, notice how it might influence your sense of purpose and connection. You're not separate from the cosmic process, but intimately part of it. Your consciousness representing one way the universe becomes aware of itself, your experiences contributing to the ongoing story of cosmic evolution. This doesn't diminish the uniqueness of individual existence, but places it within a context of infinite depth and significance. Your particular way of experiencing reality, your specific contributions to the world around you, your unique perspective on existence itself, all of these represent irreplaceable chapters in the eternal book of cosmic self-discovery. As we near the completion of our exploration, let's consider how Penrose's cyclic cosmology connects to the deepest mysteries of quantum mechanics and the nature of possibility itself. In quantum theory, reality seems to emerge from a dance of potential outcomes, with measurement or interaction selecting specific possibilities from infinite ranges of alternatives. Some interpretations suggest, though this remains highly speculative and scientifically unproven, that this process of possibility becoming actuality might operate on cosmic scales as well as quantum ones. Each cosmic cycle might represent one pathway through an infinite landscape of potential universes, with the specific physical laws, initial conditions, and evolutionary patterns that characterize our reality representing just one exploration of cosmic possibility. If this perspective has any validity, then the transition between cosmic epochs might involve a kind of universal quantum measurement event, where the infinite possibilities for how a universe might unfold collapse into the specific set of conditions that will characterize the next cycle. Take a moment to feel the profound implications of this idea. Every choice you make, every path you take through the landscape of your own possibilities, might mirror the process by which the universe itself selects pathways through the infinite space of potential realities. This creates a beautiful parallel between individual consciousness and cosmic evolution. Just as your awareness navigates through possibilities, selecting specific thoughts, emotions, and actions from infinite alternatives, the universe itself might navigate through cosmic possibilities, selecting specific physical laws and evolutionary pathways from infinite alternatives. In closing our journey through these cosmic mysteries, let's return to the fundamental question that started our exploration. What if the Big Bang wasn't actually the beginning of everything? Penrose's answer suggests that beginnings and endings might be human concepts that don't apply to ultimate reality itself. Instead of a universe with a definite start and finish, we might inhabit an eternal cosmos that continuously transforms itself, cycling through infinite variations on the themes of existence, consciousness, and cosmic evolution. Each cycle explores different possibilities, different ways of organizing matter and energy, different pathways for awareness to emerge and contemplate its own nature. This vision transforms death from an ending into a transition, individual existence from a temporary accident into a permanent contribution to cosmic evolution, consciousness from an isolated phenomenon into a fundamental aspect of reality itself. Though we must emphasize that these remain speculative interpretations rather than established scientific facts. As you reflect on your own experience of being alive, notice how it participates in this eternal conversation between mind and cosmos, individual and universal, finite and infinite. Your thoughts right now, your capacity to contemplate these profound questions, your sense of wonder at the mystery of existence, all of these represent the universe becoming conscious of itself through your particular perspective. Whether Penrose's specific theory proves correct or yields to other explanations, the questions he raises about consciousness, cosmos, and the nature of reality will continue to inspire scientific investigation and philosophical reflection. The conversation between mind and matter, observer and observed, individual awareness, and cosmic evolution continues through each moment of conscious experience. As we drift toward the end of this cosmic meditation, remember that every ending is also a beginning. Every answer reveals deeper questions. Every moment of understanding opens new territories of mystery waiting to be explored. The dialogue between consciousness and cosmos continues, and you're both participant and witness in this eternal exchange. Rest well in the wonder of existence, knowing that whether the universe is eternal or finite, cyclic or linear, your capacity to experience awe, to contemplate cosmic questions, to find meaning and beauty in the face of mystery, represents something extraordinary emerging from the cosmic process. The universe experiences itself through your consciousness, and in your awareness, existence discovers new ways of understanding itself. In our next exploration together, we'll delve into another frontier where consciousness meets the deepest puzzles of physics. Join me as we investigate how quantum mechanics might hold the key to understanding the nature of awareness itself, and why some scientists believe that consciousness could be far stranger and more fundamental than we ever imagined. Until then, may you find peace in the profound mystery of simply being aware, here and now, in this eternal moment where all possibilities converge. As we venture deeper into the mathematical landscape that makes cyclic cosmology possible, we encounter something that challenges our most basic intuitions about reality itself. The equations that govern Penrose's theory don't just describe how one universe might transition into another. They reveal a hidden architecture underlying existence, a framework where the impossible becomes inevitable and the infinite emerges from the infinitesimal. Picture yourself standing in a vast cathedral made entirely of numbers and relationships, where each arch represents a mathematical truth and every column supports another layer of cosmic possibility. This is the realm where Penrose discovered his most profound insights, not through observation alone, but through the pure logic of mathematical exploration. The key lies in understanding how infinity behaves in the mathematical world. When we say the universe expands to infinite size at the end of each cosmic epoch, we're not talking about a simple matter of getting bigger and bigger forever. We're describing a state where the very concepts of size and distance lose their meaning, where geometry itself undergoes a fundamental transformation. In this ultimate future state, when all massive particles have decayed and only photons remain, something extraordinary happens to the mathematics of space-time. The equations that describe this infinite, massless universe become mathematically identical to those describing a point-like singularity ready to explode into a new Big Bang. It's as if the universe discovers a secret passage between the infinitely large and the infinitesimally small. Take a breath and consider what this means. The mathematical structure of reality itself might contain hidden doorways, passages between states that seem completely opposite but are actually deeply connected. The end becomes the beginning, not through some external miracle, but through the internal logic of mathematics itself. This mathematical equivalence reveals something profound about the nature of scale and proportion in our universe. We're accustomed to thinking of size as absolute, where large things are definitively different from small things. But Penrose's work suggests that at the extremes, these distinctions might dissolve into something more fluid and interconnected. Consider how this might appear in your own experience. When you listen to music, individual notes combine to create melodies, melodies weave together into harmonies, and harmonies build into symphonies. At each level, new properties emerge that weren't present in the individual components, yet the symphony remains intimately connected to each single note that comprises it. The universe might work similarly across scales of size and time that dwarf even our most expansive imagination. Quantum fluctuations in the early universe become the seeds of galaxies. Stellar evolution creates the elements necessary for planetary formation. Planetary environments provide the conditions for biological complexity to emerge, and consciousness develops the capacity to contemplate the cosmos that gave birth to it. In Penrose's cyclic framework, this process doesn't end with the heat death of our current universe. Instead, it continues into scales so vast that entire cosmic epochs become like individual notes in an eternal symphony, each one contributing its unique voice to a composition that never reaches a final movement. As you reflect on your place within this cosmic symphony, notice how your individual existence participates in patterns that extend far beyond any single lifetime or cosmic epoch. Every breath you take involves atoms that were forged in stellar cores. Every thought you think depends on neural processes that emerged from billions of years of biological evolution. Every moment of consciousness represents the universe becoming aware of itself through your particular perspective. But perhaps the most intriguing aspect of this mathematical framework involves how information might be preserved and transmitted across cosmic boundaries. In our current understanding of physics, information cannot be created or destroyed, only transformed. This principle, known as information conservation, creates fascinating puzzles when applied to cosmic evolution. Imagine trying to compress the entire contents of the universe, every particle position, every quantum state, every complex pattern that emerged during billions of years of cosmic evolution, into a form that could survive the transition between cosmic epochs. It seems impossible, like trying to fold an entire library into a single page without losing any of the information contained in all those books. Yet black holes might provide the mechanism for exactly this kind of cosmic information processing. As these gravitational giants consume matter and energy throughout their lifetimes, they might not simply destroy the information they absorb. Instead, they could encode it in incredibly subtle patterns, mathematical relationships that become embedded in the fabric of space-time itself. When black holes eventually collide and merge, they release gravitational waves that carry these encoded patterns outward through the cosmos. These waves would be among the last signals transmitted in each cosmic epoch, carrying compressed information about the entire history of universal evolution into the initial conditions of the next cycle. Take a moment to contemplate the profound implications of this possibility. Every star that ever shone, every planet that ever formed, every moment of complexity that ever emerged might leave traces that influence how future universes unfold. Nothing would be truly lost, only transformed and transmitted through channels we're just beginning to understand. This brings us to one of the most puzzling aspects of trying to investigate these cosmic scale phenomena. How do you study processes that occur across timescales longer than the current age of the universe? How do you gather evidence for events that supposedly occurred before our universe even began? The cosmic microwave background radiation that fills our sky represents our most direct window into the early universe. Light that has been travelling since the cosmos was only a few 100,000 years old. But according to Penrose's theory, this ancient glow might contain information from even earlier epochs, patterns that somehow survived the transition between one universe and the next. Detecting such patterns requires extraordinary sensitivity and sophisticated analysis techniques. The signals would be incredibly faint, subtle variations in temperature and polarization that could easily be confused with instrumental noise or statistical fluctuations. It's like trying to hear a whisper in the middle of a thunderstorm, or detect the shadow of a butterfly cast by starlight. This is why the scientific community has been so divided about Penrose's claimed observations. The evidence he presents is at the very limit of what current technology can detect, and the statistical methods required to extract signal from noise are complex and potentially controversial. Different analysis techniques can lead to completely different conclusions about what the data reveals. As you consider this challenge, notice how it mirrors the difficulties we face in understanding subtle phenomena in our own lives. Sometimes the most important patterns are the hardest to detect, requiring patience, attention, and willingness to look beyond surface appearances. The process of discovery often involves learning to see signals that were always there, but previously overlooked or misinterpreted. These questions about evidence and observation connect to deeper philosophical puzzles about the nature of time itself. In our everyday experience, time flows like a river, carrying us from past toward future in a direction we cannot control or reverse. But in the mathematical framework of physics, time often behaves more like a dimension of space, something that can be traversed in multiple directions. Einstein's theories revealed that time and space are intimately connected, forming a unified four-dimensional fabric called space-time. Events that appear simultaneous to one observer might occur at different times for another observer moving at high speed. The flow of time itself can slow down or speed up depending on gravitational fields and relative motion. Penrose's cyclic cosmology pushes these insights to their ultimate conclusion, suggesting that time itself might be circular rather than linear. Instead of flowing from a definite beginning toward a final ending, cosmic time might loop back on itself, connecting the infinite future to the infinite past in an eternal cycle. This transforms our understanding of concepts like causation and consequence. In a linear timeline, causes precede effects in a clear temporal order. But in a cyclic timeline, the relationship between cause and effect becomes more complex and interconnected. Events in one cosmic epoch might influence conditions in subsequent cycles, creating feedback loops that extend across timescales we can barely comprehend. Take a breath and imagine what it might feel like to exist in such a temporal framework. Your individual life, with its clear progression from birth through growth to eventual death, would be embedded within cosmic cycles so vast that the entire history of human civilization represents barely a moment in cosmic time. This cyclical view of cosmic time raises profound questions about meaning and purpose in individual existence. If the universe truly undergoes infinite cycles of evolution, if every possible outcome eventually occurs somewhere in the endless sequence of cosmic epochs, what significance can individual choices and actions have? Some interpretations might suggest that in an infinite universe with infinite cycles, everything that can happen does happen, making individual decisions irrelevant to the larger cosmic story. It's a perspective that could lead to fatalism or nihilism, the sense that nothing we do ultimately matters because all possibilities will be explored anyway. But consider the alternative perspective that emerges from deeper reflection on these ideas. In an eternal cosmos where information and complexity persist across cosmic boundaries, every action becomes infinitely significant. The patterns of consciousness, creativity, and connection that you generate might contribute to the cosmic information that influences how future universes unfold. Your particular way of experiencing reality, your specific contributions to the communities and relationships around you, your unique perspective on existence itself, these might not be temporary accidents, but permanent features of cosmic evolution. Every moment of awareness, every act of kindness, every creative expression might leave traces that echo through infinite future cycles. This doesn't require belief in any supernatural mechanism or mystical connection between individual consciousness and cosmic evolution. It simply recognizes that in a universe where information is conserved and complexity emerges naturally from simple laws, conscious beings like ourselves represent incredibly sophisticated patterns of information processing and creative expression. As you reflect on your own sense of purpose and meaning, notice how these cosmic perspectives might influence your understanding of significance. Rather than diminishing the importance of individual existence, the possibility of cosmic cycles might actually amplify it, placing every conscious moment within a context of infinite depth and eternal duration. Throughout our exploration of these profound ideas, one theme has remained constant: the capacity for wonder and curiosity that allows conscious beings to contemplate questions far beyond their immediate experience. This capacity itself represents something remarkable emerging from cosmic evolution. Think about what it means that the universe has evolved patterns of matter and energy capable of contemplating their own origins. After billions of years of cosmic evolution, stellar nucleosynthesis, planetary formation, and biological development, the cosmos has given rise to beings who can ask questions about the nature of existence itself. You are not separate from this cosmic process, but intimately part of it. The atoms in your body were forged in stellar cores. The molecules that enable your neural activity emerged from complex chemical evolution, and the consciousness that allows you to contemplate these mysteries represents the universe becoming aware of itself through your particular perspective. This self-referential quality creates beautiful feedback loops between observer and observed, between consciousness and cosmos, between individual awareness and universal evolution. Every moment of wonder, every question about the nature of reality, every attempt to understand cosmic origins represents the universe investigating itself through conscious beings that emerge from its own evolutionary processes. Take a moment to feel the profound mystery of this situation. You are the cosmos becoming conscious of itself, matter and energy, organized into patterns capable of contemplating their own existence. Whether the universe follows Penrose's cyclic model or some other framework, this emergence of consciousness from cosmic evolution remains one of the most remarkable phenomena we can observe. As we approach the conclusion of our journey through these cosmic mysteries, it's important to acknowledge the fundamental limits that constrain our understanding of ultimate questions. Human consciousness evolved to navigate environments very different from the cosmic scales we've been exploring, and our conceptual frameworks might not be adequate for fully comprehending the deepest aspects of reality. We are finite beings attempting to understand infinite processes using tools and concepts that developed for very local and limited purposes. Perhaps it's not surprising that our investigations of cosmic origins lead us to profound paradoxes and unresolved questions that challenge the boundaries of what can be known through scientific investigation. The beauty lies not in having final answers, but in the ongoing process of inquiry itself. Each new theory, each novel observation, each creative interpretation adds another layer to our understanding, even when it doesn't provide definitive resolution to the deepest mysteries. Penrose's work, regardless of whether his specific claims prove correct, represents this spirit of bold inquiry that pushes against the boundaries of established knowledge. By proposing radical alternatives to conventional cosmology, by searching for subtle patterns in ancient light, by connecting mathematical insights to observational possibilities, he embodies the kind of creative thinking that drives scientific progress. As you consider your own relationship with mystery and understanding, notice how the process of questioning itself might be as valuable as any specific answers we discover. The capacity to wonder, to explore possibilities beyond immediate experience, to find meaning and beauty in cosmic questions. These represent profound achievements of consciousness, regardless of what ultimate truths they might reveal. In these final moments of our exploration, let's return to the fundamental vision that inspired our journey. The possibility that our universe participates in an eternal dance of cosmic evolution, cycling through infinite variations on the themes of existence, consciousness, and creative expression. Whether or not Penrose's specific theory proves correct, the questions he raises invite us to expand our conception of what reality might actually be. Instead of a universe with definite beginnings and endings, we might inhabit something more like an eternal improvisation, where fundamental patterns persist while specific details vary across timescales and spatial scales that dwarf human comprehension. This perspective transforms our understanding of individual significance within cosmic context. Rather than being temporary accidents in an indifferent universe, conscious beings might represent permanent features of cosmic evolution, ways that matter and energy organize themselves into patterns capable of awareness, creativity, and wonder. And your consciousness, your capacity to contemplate these profound questions, your experience of beauty and meaning in the face of cosmic mystery, these might not be fleeting accidents, but fundamental aspects of how the universe becomes aware of itself. Every moment of conscious experience represents a unique perspective on existence that has never occurred before and will never be repeated exactly. Take a deep breath and feel the weight and wonder of this possibility. You are not separate from the cosmic process, but intimately woven into its fabric. Your thoughts, your emotions, your sense of connection to something larger than yourself, all of these represent the universe experiencing itself through the particular pattern of consciousness that you are. As we drift toward the end of this cosmic meditation, carry with you a sense of profound interconnectedness with the largest scales of space and time. Whether the universe is eternal or finite, cyclic or linear, your capacity to experience awe, to ask meaningful questions, to find beauty in mystery itself, represents something extraordinary emerging from cosmic evolution. The conversation between consciousness and cosmos continues through every moment of awareness, every act of curiosity, every recognition of wonder in the face of existence itself. You are both participant and witness in this eternal dialogue, contributing your unique voice to a cosmic symphony that may have no beginning and no end. Rest well in this profound mystery, knowing that the questions we've explored together will continue to inspire scientific investigation and philosophical reflection long after our particular exploration concludes. The universe may or may not be caught in eternal cycles of death and rebirth, but the human capacity to contemplate such possibilities, to find meaning in cosmic questions, to experience wonder at the mystery of existence, these remain undeniable realities that connect us to something infinitely larger than ourselves. Join me next time as we venture into another frontier where consciousness meets the deepest puzzles of quantum reality. In This Quantum Consciousness Theory Terrifies Scientists, we'll explore why some researchers believe that awareness itself might be far stranger and more fundamental than we ever imagined, and how the quantum realm might hold keys to understanding the nature of mind that challenge everything we thought we knew about consciousness and reality. Until then, may you find peace in the profound mystery of simply being aware, here and now, in this eternal moment where all cosmic possibilities converge into the singular miracle of conscious experience. Yet despite the elegance of Penrose's mathematical framework, the scientific community has raised fundamental objections that strike at the very heart of his theory. These aren't merely technical quibbles or academic disagreements, they represent profound challenges to the basic assumptions that make cyclic cosmology possible, questions that force us to confront the limits of what we can know about ultimate reality. The most serious challenge involves a deceptively simple question. What happens to mass? In Penrose's model, the transition between cosmic epochs requires that all massive particles eventually decay into massless photons. Only when the universe contains nothing but light can the mathematical equivalence between infinite expansion and singular compression take hold. But here's the problem that keeps theoretical physicists awake at night. According to our current understanding of particle physics, many fundamental particles appear to be absolutely stable. Electrons, for instance, show no signs of decay even after billions of years of observation. The standard model of particle physics, our most successful theory of matter and energy, provides no mechanism by which electrons could lose their mass or electric charge. Take a moment to consider what this means. Penrose's beautiful mathematical structure might be describing a universe that simply cannot exist according to the laws of physics as we currently understand them. It's like discovering a perfect architectural blueprint for a building that requires materials with impossible properties. Some speculative extensions of the standard model do suggest that protons might eventually decay, though this has never been observed despite decades of careful experimentation. But even these exotic theories say nothing about electron decay, and electrons are among the most fundamental constituents of matter. As you reflect on this challenge, notice how it mirrors the difficulties we face when trying to implement beautiful ideas in practical reality. Sometimes our most elegant theories encounter stubborn facts that refuse to cooperate with our conceptual frameworks. Even more troubling for Penrose's theory is what cosmologists call the entropy problem. While his model attempts to explain why the early universe had such extraordinarily low entropy, critics argue that it might actually make the problem worse rather than better. Remember that entropy measures disorder, and the second law of thermodynamics requires entropy to increase over time. In Penrose's cyclic model, each universe begins with very low entropy and evolves toward maximum entropy before transitioning to the next cycle. But how can this transition actually reduce entropy to the incredibly low levels required for a new Big Bang? Penrose suggests that black hole evaporation removes entropy from the universe, but many physicists question whether this mechanism is sufficient. The calculations are extraordinarily complex, involving quantum mechanics, general relativity, and thermodynamics operating under extreme conditions that we've never directly observed. Some critics argue that Penrose's model doesn't actually solve the fine-tuning problem it was designed to address. Instead of explaining why our universe began with such precisely ordered initial conditions, it simply assumes that some unknown mechanism can reset cosmic entropy at the end of each cycle. It's a bit like explaining why your room is clean by saying that invisible elves tidy it up every night. The explanation might account for the observed phenomenon, but it introduces new mysteries that are even more difficult to understand than the original puzzle. Picture yourself trying to solve a jigsaw puzzle by constantly adding new pieces. Each addition might seem to help, but eventually you realize that you're making the puzzle more complex rather than bringing it closer to completion. The debate over Penrose's claimed observational evidence reveals something profound about the nature of scientific truth and the challenges of detecting subtle signals in noisy data. When multiple independent research groups analyze the same cosmic microwave background radiation and reach opposite conclusions, what does this tell us about the reliability of our observational methods? The controversy centers on statistical analysis techniques, the mathematical tools we use to determine whether patterns in data are real signals or random fluctuations. Different approaches to this analysis can yield dramatically different results, like looking at the same cloud formation and seeing either a dragon or a sailing ship depending on your perspective and expectations. 3 independent research teams attempted to reproduce Penrose's findings using what they considered standard statistical methods. All 3 found no evidence for the concentric circles or Hawking points that Penrose claimed to detect. Yet Penrose and his collaborators maintain that their alternative analysis techniques reveal clear signals that others are missing. This isn't simply a matter of who's right and who's wrong. It highlights fundamental questions about how we extract meaning from complex data, how we distinguish between signal and noise, and how our analysis methods might unconsciously bias the conclusions we reach. Take a breath and consider how this applies to your own attempts to understand complex situations. Sometimes, the same events can be interpreted in completely different ways depending on the framework you use to analyze them. The challenge lies in remaining open to multiple perspectives while still being able to make meaningful decisions based on the best available evidence. The scientific community's response to Penrose's claims reveals both the strengths and limitations of how we establish consensus about controversial ideas. On one hand, the rigorous peer review process helps identify potential flaws and alternative explanations. On the other hand, established paradigms can sometimes be slow to accept genuinely revolutionary insights. Most cosmologists continue to support the standard model of Big Bang cosmology enhanced by inflation theory. This framework successfully explains a wide range of observational phenomena, from the cosmic microwave background radiation to the large-scale structure of galaxies to the abundance of light elements in the universe. Penrose's cyclic cosmology, while mathematically sophisticated and conceptually intriguing, struggles to match the predictive success of the standard model. It requires additional assumptions about particle physics that have no experimental support, and its claimed observational signatures remain disputed by most researchers in the field. Yet this doesn't necessarily invalidate Penrose's approach. Throughout the history of science, revolutionary ideas have often faced initial skepticism from the established community. Continental drift, quantum mechanics, and the expansion of the universe all encountered significant resistance before eventually being accepted. The key question is whether Penrose's theory will eventually overcome its current challenges through new evidence and theoretical developments, or whether it represents a beautiful mathematical possibility that doesn't correspond to physical reality. As you contemplate this scientific drama, notice how it mirrors the process of personal growth and understanding. Sometimes our most cherished beliefs and assumptions need to be questioned and potentially revised in light of new evidence or alternative perspectives. This brings us to one of the most fundamental questions in the philosophy of science. What level of evidence should be required before accepting extraordinary claims about the nature of reality? Carl Sagan famously observed that extraordinary claims require extraordinary evidence, but who decides what counts as extraordinary and what constitutes sufficient proof? Penrose is asking the scientific community to consider the possibility that our entire conception of cosmic origins is fundamentally mistaken. He's suggesting that the Big Bang wasn't a beginning, but a transition, that our universe is one of infinitely many in an eternal cycle of cosmic evolution, and that we can detect traces of previous universes in the patterns of ancient light. These are indeed extraordinary claims that, if proven correct, would revolutionize our understanding of existence itself. The level of evidence required to support such claims must be correspondingly robust, clear, and reproducible by independent researchers using different methods and assumptions. So far, the evidence remains controversial and disputed. The statistical patterns that Penrose claims to detect could potentially be explained by more conventional processes within the standard cosmological model. The theoretical requirements of his model, particularly the assumption that all massive particles eventually decay, lack support from established particle physics. This doesn't mean Penrose is wrong, but it does mean that extraordinary evidence has not yet been provided for his extraordinary claims. The scientific process requires patience, continued investigation, and willingness to revise conclusions based on accumulating evidence. Take a moment to reflect on how this principle might apply to your own evaluation of new ideas and claims. What standards do you use to distinguish between possibilities worth considering and assertions that require more substantial support? Despite the controversies and criticisms, Penrose's work serves an invaluable function in the scientific ecosystem by challenging established assumptions and forcing researchers to examine their foundational beliefs more carefully. Even if his specific theory proves incorrect, the questions he raises about cosmic origins, entropy, and the nature of time will continue to inspire new investigations and alternative approaches. Science progresses not only through the accumulation of confirming evidence, but also through the creative tension between competing ideas. Each new theory, even if ultimately unsuccessful, contributes to our understanding by revealing new aspects of the problems we're trying to solve and suggesting novel approaches to investigation. The standard model of cosmology, despite its remarkable success, still faces unresolved puzzles. The nature of dark matter and dark energy, the precise mechanism of cosmic inflation, the ultimate fate of the universe, all of these remain active areas of research where new insights might emerge. Penrose's cyclic cosmology represents one attempt to address these puzzles through a radically different framework. Whether or not it succeeds, it demonstrates the kind of bold theoretical thinking that drives scientific progress by pushing beyond comfortable assumptions toward new possibilities. As you consider the role of dissent and alternative perspectives in your own life, notice how challenging ideas can sometimes clarify and strengthen your understanding, even when you ultimately reject them. The process of examining and responding to different viewpoints often reveals aspects of issues that might otherwise remain hidden. While these cosmic debates might seem far removed from daily experience, they connect to fundamental questions about how we understand our place in the universe and the meaning we find in existence itself. Whether the universe began with a Big Bang or emerged from an eternal cycle of cosmic evolution has profound implications for how we think about purpose, significance, and our relationship to the larger reality that contains us. If the standard cosmological model is correct, then we live in a universe that had a definite beginning and will likely have a definite end. Our cosmic epoch represents a unique chapter in the story of existence, unrepeatable and precious precisely because it is temporary and fragile. In this framework, consciousness and life represent remarkable achievements of cosmic evolution, patterns of complexity that emerged against enormous odds from initially simple conditions. Every moment of awareness, every creative act, every expression of love and compassion becomes significant as a rare flowering of the universe's potential for beauty and meaning. Alternatively, if Penrose's cyclic model proves correct, then we participate in an eternal cosmic process that has no beginning and no end. Consciousness and complexity represent not accidents, but inevitable features of cosmic evolution, patterns that emerge naturally in each cycle and contribute to the ongoing story of universal self-discovery. In this framework, individual existence gains significance, not from its rarity, but from its participation in an infinite creative process. Every experience becomes part of an eternal conversation between matter and consciousness, individual and universal, finite and infinite. Take a breath and notice how these different cosmological visions might influence your sense of meaning and purpose. Does it matter whether the universe is temporary or eternal? Does significance depend on rarity or on participation in something larger than ourselves? These questions about cosmic origins and ultimate reality also raise important ethical considerations about how we present and discuss highly speculative scientific ideas. When distinguished scientists like Penrose make extraordinary claims, how do we balance respect for creative thinking with responsibility to maintain scientific rigor and public understanding? The media attention surrounding Penrose's work demonstrates both the benefits and risks of public engagement with cutting-edge science. On one hand, discussing these profound questions can inspire wonder, curiosity, and appreciation for the remarkable achievements of human investigation. On the other hand, presenting disputed claims without adequate context can contribute to misunderstanding about how science actually works. Science is not a collection of established facts, but an ongoing process of investigation, debate, and gradual consensus building. The ideas that eventually become accepted scientific knowledge usually go through extended periods of questioning, testing, and refinement before gaining widespread support. Penrose's work exemplifies this process in action. His mathematical insights about black holes revolutionized our understanding of these cosmic objects and earned him a Nobel Prize. His current claims about cyclic cosmology continue to undergo the same process of scrutiny and evaluation that characterizes healthy scientific investigation. As you encounter scientific claims in media and popular discussions, notice the difference between established knowledge that has survived extensive testing and speculative ideas that remain under investigation. Both play important roles in the scientific process, but they deserve different levels of confidence and different types of consideration. Perhaps the most profound lesson from our exploration of these cosmic questions is the recognition that mystery itself plays an essential role in driving human understanding forward. The deepest questions about existence, consciousness, and cosmic origins remain fundamentally open, inviting continued investigation and wonder. Whether the universe follows Penrose's cyclic model, the standard Big Bang framework, or some entirely different pattern we haven't yet imagined, the fact that conscious beings like ourselves can contemplate such possibilities represents something extraordinary emerging from cosmic evolution. The capacity for wonder, the ability to ask questions that extend far beyond immediate practical concerns, the drive to understand our place in the larger scheme of existence. These distinctively human qualities connect us to the deepest mysteries of reality itself. You are not separate from the cosmic processes that gave rise to galaxies, stars, and planets. The atoms in your body were forged in stellar cores, The molecules that enable your thoughts emerged from billions of years of chemical evolution, and the consciousness that allows you to contemplate these mysteries represents the universe becoming aware of itself through your particular perspective. This remains true regardless of which cosmological model eventually proves correct. Whether the universe began 13.8 billion years ago or has been cycling through infinite epochs, your capacity to experience awe, to ask meaningful questions, to find beauty in cosmic mystery itself, represents something profound emerging from the fundamental processes that shape reality. Take a moment to feel the weight and wonder of this recognition. Every breath connects you to the cosmic processes that created the elements necessary for life. Every thought depends on neural activities that emerged from evolutionary processes stretching back to the origins of complexity itself. As our exploration of these profound questions draws toward a close, remember that ending any investigation of cosmic mysteries is really just a pause in an ongoing conversation that extends far beyond any individual exploration. The questions we've examined together will continue to inspire scientific research, philosophical reflection, and personal wonder long after our particular discussion concludes. The beauty of engaging with these deep questions lies not in reaching final answers, but in participating in the eternal human dialogue with mystery itself. Every generation discovers new ways of asking ancient questions, new tools for investigating fundamental problems, new perspectives on the relationship between individual existence and cosmic reality. Penrose's work, whether ultimately vindicated or superseded, represents this spirit of bold inquiry that characterizes the best of human intellectual achievement. By proposing radical alternatives to established ideas, by searching for subtle signals in ancient light, by connecting mathematical insights to observational possibilities, he embodies the creative thinking that drives understanding forward. The scientific method provides a framework for evaluating competing ideas, but it cannot eliminate the wonder and mystery that motivate investigation in the first place. Some questions may never be answered definitively, but the process of asking them transforms our understanding of what it means to exist in this remarkable cosmos. As you move forward from this exploration, carry with you an appreciation for both the power and limits of human understanding. We have developed extraordinary tools for investigating reality, from mathematical frameworks that describe cosmic evolution to instruments that detect ancient light from the edge of the observable universe. Yet fundamental questions about consciousness, cosmic origins, and the nature of existence itself remain beautifully open, inviting continued exploration and wonder. The conversation between human curiosity and cosmic mystery continues through every moment of conscious questioning, every scientific investigation, every recognition of awe in the face of reality's profound depth. In these final moments of our journey together, let's return to the immediate reality of this present moment, the eternal now in which all experience actually occurs. Whether the universe is eternal or finite, cyclic or linear, the fact of your awareness right now remains the fundamental ground of your existence. Take a deep breath and notice the miracle of being conscious in this moment. Your capacity to contemplate cosmic questions, to wonder about ultimate origins, to find meaning in mystery itself represents something extraordinary that has emerged from whatever processes govern reality at its deepest levels. The thoughts flowing through your awareness right now, the sense of connection you might feel to something larger than yourself, your experience of curiosity and wonder in the face of cosmic questions, these represent the universe becoming conscious of itself through your particular perspective. This recognition doesn't depend on accepting any specific cosmological theory or scientific claim. It simply acknowledges the profound mystery of consciousness itself, the remarkable fact that matter and energy have organized themselves into patterns capable of awareness, reflection, and wonder. Whether Penrose's vision of eternal cosmic cycles proves correct or the standard model of Big Bang cosmology continues to provide our best framework for understanding cosmic origins, the emergence of consciousness from cosmic evolution remains one of the most astonishing phenomena we can observe. You are not an accident or an afterthought in the cosmic story. You are consciousness itself, the universe's way of experiencing and understanding its own nature. Every moment of awareness represents a unique perspective on existence that has never occurred before and will never be repeated exactly. Rest in this profound recognition as we prepare to conclude our exploration. The questions we've examined together about cosmic origins, eternal cycles, and the nature of reality will continue to inspire investigation and wonder. But the immediate fact of your conscious presence in this moment represents something equally mysterious and profound. As we drift toward the end of this cosmic meditation, remember that every conclusion opens new territories of mystery waiting to be explored. The conversation between consciousness and cosmos continues through every moment of awareness, every act of curiosity, every recognition of beauty in the face of the unknown. The profound questions raised by Penrose's work about cosmic cycles, information conservation, and the relationship between mind and reality connect to even deeper mysteries about the nature of consciousness itself. If the universe can undergo cycles of death and rebirth, if information can persist across cosmic boundaries, what might this suggest about awareness and its relationship to the fundamental structure of reality? Some researchers have proposed connections between consciousness and quantum mechanics that are even more radical than Penrose's cosmological theories, suggesting that awareness itself might operate through quantum processes that bridge the gap between mind and matter in ways we're only beginning to explore. These ideas remain highly speculative and controversial, challenging our most basic assumptions about the relationship between subjective experience and objective reality. Yet they arise naturally from serious attempts to understand how consciousness emerges from physical processes and how the act of observation seems to play a fundamental role in quantum mechanical phenomena. The implications stretch far beyond academic physics into questions about free will, the nature of reality, and the possibility that consciousness might be far stranger and more fundamental than we ever imagined. Some interpretations even suggest that awareness itself could be woven into the basic fabric of existence, though this remains entirely unproven and lacks scientific consensus. Join me next time as we venture into this even more mysterious territory where quantum mechanics meets the deepest puzzles of consciousness. In This Quantum Consciousness Theory Terrifies Scientists, we'll explore why some researchers believe that the nature of awareness itself might hold keys to understanding reality that challenge everything we thought we knew about mind, matter, and the relationship between observer and observed. Until then, rest well in the profound mystery of simply being aware, knowing that your consciousness represents something extraordinary, emerging from whatever processes govern the deepest levels of reality. Whether the universe is eternal or temporary, cyclic or linear, your capacity to experience wonder, to contemplate cosmic questions, and to find meaning in mystery itself connects you to the most profound aspects of existence. The cosmos dreams through your awareness, and in your consciousness, reality discovers new ways of understanding itself. Sleep peacefully in this recognition, carrying with you a sense of profound connection to the largest questions and deepest mysteries that consciousness can contemplate. Yet even as we contemplate these profound possibilities, we must acknowledge the fundamental uncertainty that surrounds all attempts to understand cosmic origins. The very nature of investigating events that supposedly occurred before our universe began creates methodological challenges that push against the limits of what science can accomplish. Consider the peculiar situation we find ourselves in. We are patterns of matter and energy that emerged from cosmic evolution using tools and concepts that developed within this same cosmic context. to investigate the ultimate nature of the reality that gave birth to us. It's a bit like asking a wave to step outside the ocean and describe the nature of water itself. This recursive quality creates both opportunities and limitations for understanding. On one hand, we are not external observers, but intimate participants in the cosmic processes we're trying to comprehend. Our consciousness represents the universe becoming aware of itself, which provides a unique insider's perspective on the nature of existence. On the other hand, our embeddedness within the cosmic process means that our tools, concepts, and ways of thinking are all shaped by the same evolutionary pressures and physical constraints that govern everything else in our observable reality. We might be like characters in a story trying to understand the nature of storytelling itself. As you reflect on these limitations, notice how they mirror the challenges we face in understanding any complex system from within. When you try to understand your own thought processes, you're using the very thinking patterns you're attempting to analyze. When you examine your emotional responses, you're employing the same emotional systems you're trying to comprehend. The controversy surrounding Penrose's claims reveals something profound about the relationship between mathematical elegance and physical reality. His theory possesses undeniable mathematical beauty, with equations that connect concepts across vast scales of space and time in ways that feel almost poetic in their symmetry and completeness. Yet mathematical beauty, while often a guide to truth in physics, provides no guarantee of correspondence with actual reality. History is filled with theories that were mathematically sophisticated and conceptually appealing, but ultimately failed to match what we observe in the natural world. The challenge lies in distinguishing between mathematical possibility and physical actuality. Just because we can write equations that describe cyclic universes doesn't necessarily mean such universes exist. Just because we can imagine information persisting across cosmic boundaries doesn't prove that such persistence actually occurs. This tension between mathematical idealization and messy physical reality reflects a deeper question about the relationship between mind and cosmos. To what extent do the patterns we discover in nature reflect the structure of reality itself? And to what extent do they reveal the particular ways our evolved cognitive systems organize and interpret experience? So where does this leave us in our quest to understand cosmic origins and our place within the grand tapestry of existence? After wandering through mathematics that blur the boundaries between infinite and infinitesimal, after contemplating cycles that stretch across timescales our minds can barely grasp, after examining claims of ancient light carrying whispers from universes that preceded our own, we find ourselves returned to the fundamental mystery that sparked our journey. Whether Penrose's revolutionary vision proves correct or yields to other explanations, something profound has emerged from our exploration. We've discovered that the deepest questions about reality resist easy answers, that the universe continues to surprise us with possibilities we never imagined, and that consciousness itself represents one of the most remarkable phenomena to emerge from cosmic evolution. The scientific process will continue its patient work of testing, questioning, and refining our understanding. New observations will either support or challenge Penrose's claims about concentric circles and Hawking points in the cosmic microwave background. Future theoretical developments may resolve the puzzles about particle decay and entropy that currently challenge cyclic cosmology. The conversation between bold speculation and careful evidence will go on, as it always has, pushing the boundaries of what we can know about ultimate reality. But perhaps the most valuable insight from our journey isn't about cosmic cycles or infinite universes or mathematical equivalencies between endings and beginnings. Perhaps it's the recognition that you, sitting here in this moment, represents something extraordinary that has emerged from whatever processes govern the deepest levels of reality. Your capacity to contemplate these profound questions, to find wonder in cosmic mysteries, to experience awe at the sheer fact of existence itself. These qualities connect you to the most fundamental aspects of what it means to be conscious in this remarkable cosmos. The universe may or may not be eternal and cyclic, but your ability to ponder such possibilities, to find meaning in questions that extend far beyond immediate practical concerns, to experience beauty in the face of mystery, these represent undeniable realities that persist regardless of which cosmological model eventually proves correct. In contemplating the cosmos, you are the cosmos contemplating itself, and that recursive wonder remains one of the most beautiful aspects of existence. Until we meet again in our next exploration of consciousness and quantum reality, rest well in the profound mystery of simply being aware, here and now, in this eternal present moment, where all possibilities converge into the singular miracle of conscious experience. Singular miracle of conscious experience.